Hi everyone, this is your math guru. Today we're going to be solving exponential equations using the following examples. In the first example, we have 5 to the power of x plus 2 plus 5 to the power of x equals 26. Using the laws of exponent, we know that if I have a base, x, multiplied by a to the power of y, because the base are the same, we're going to be adding the exponent. That's going to be a to the power of x plus y. So expanding each of these exponents, we have 5x plus 2 in expanded form is the same as 5 to the power of x times 5 to the power of 2 plus 5 to the power of x equals 26. If you notice, I have 5 to the power of x common to both terms, so I'm going to factorize 5 to the power of x. I'm left with 5 to the power of 2 plus 1 equals 26. 5 to the power of x in bracket 5 squared, that's 5 times 5, 25 plus 1 equals 26. 5 to the power of x, 25 plus 1, that's times 26 equals 26. I'm looking for x. I'm going to be dividing both sides by 26. This cancels. I'm left with 5 to the power of x equals to 1. Laws of exponents states that any variable or any number to the power of 0 is 1. And so to put 1 to the base of 5, I know that 5 to the power of 0 is the same as 1. Therefore, 5 to the power of x is the same as 5 to the power of 0. And once the base are the same, I'm going to equate the exponent or the powers. So therefore, x equals to 0. In the second example, we have 5 to the power of 3x minus 5 30x minus 1 equals to 4. I'm going to be expanding my exponent. I have 5 to the power of 3x minus 5 to the power of 3x times 5 to the power of minus 1 equals to 4, just like I did in the last example. And if I find something common to both terms, I know that 5 to the power of 3x is common to both terms. So if I factorize 5 to the power of 3x, I'm left with 1 minus 5 to the power of minus 1 equals to 4. 5 to the power of 3x in bracket 1 minus negative exponent. If I have a to the power of minus 1, writing it as a fraction is same as 1 over a. So therefore, 5 to the power of minus 1, writing it as a fraction is 1 over 5. Replacing that in my equation, I have 1 minus 1 over 5 equals to 4. I have 5 to the power of 3x times 1 minus 1 over 5, that's 4 over 5 equals to 4. I'm going to be dividing both sides by 4 over 5. So I have over 4 over 5 divided by 4 over 5. This cancels. I'm left with 5 to the power of 3x equals, I know that 4 divided by 4 over 5 is the same thing as 4 over 1 times 5 over 4. This cancels, so this will give me 5. So this is equal to 5. There's an invisible one here. And because the base are the same, I'm going to equate the powers. I have 3x equals to 1. Therefore, my x equals 1 over 3, dividing both sides by 3. In this example, I have 2 to the power of x minus 5 times 2 to the power of x plus 1 equals minus 144. If I split up my exponents, I have 2 to the power of x minus 5 times 2 to the power of x times 2 to the power of 1 equals minus 144. If I check the two terms, 2 to the power of x is common, so I'm going to factorize 2 to the power of x. I'm left with, on my left hand side, 1 minus, on my right hand side, 5 times 2 equals minus 144. 2 to the power of x in bracket 1 minus 5 times 2 is 10 equals 144. I have 2 to the power of x times 1 minus 10 is minus 9 equals minus 144. I'm going to divide both sides by minus 9. This cancels. I'm left with 2 to the power of x equals minus 144 divided by 9. I have 16. The base are not the same, so I'm going to change my 16 using prime factorization. I have 2 times 2 times 2 times 2, and that will give me 2 to the power of 4. And substituting back, I have 2 to the power of x equals 2 to the power of 4. The base are now the same, so therefore I'm going to equate the powers. X equals 2, 4. Let's look at one more example. In this example, I have 3 to the power of 2 minus x minus 3 to the power of minus x minus 3 equals 242 over 9. I'm going to split up my terms. On my left hand side, I have 3 to the power of 2 times 3 to the power of minus x minus 3 to the power of minus x times 3 to the power of minus 3 equals 242 over 9. If I check the two terms, 3 to the power of minus x is common, so I'm going to factorize 3 to the power of minus x. On my left hand side, I have 3 squared minus 3 to the power of minus 3 equals 242 over 9. 3 to the power of minus x in bracket 3 squared will give me 9 minus, if I change, I have a minus 1 is the same, writing it as a fraction is the same as 1 over a. So 3 minus 3 is the same as 1 over 3 to the power of 3, which is the same thing as 1 over 3 times 3, 9, 9 times 3, 27. So I'm going to slot that back into my equation. I have 9 minus 1 over 27 equals 242 over 9. If I change that, I have 3 to the power of minus x times 242 over 27. It's equal to 242 over 9. If I divide both sides by 242 over 27, I'm left with 3 to the power of minus x equals 242 over 9 divided by 242 over 27, which is the same as, I have 3 minus x, 242 over 9, this flips, 27 over 242, let's cancel, 9 here 1, 9 here 3. So that's going to give me 3 to the power of 1. And as soon as I can see that my base are the same, I'm going to equate the powers. I have minus x equals to 1, so therefore my positive x equals to minus 1. Thanks for watching. Bye.